Hello everyone, my name is Nick Sotakos and I am an assistant professor of biology at Penn State Harrisburg. In today's video, I am going to describe my research on diabetic kidney disease. Everyone knows people who have suffered or are suffering from diabetes, but not everyone realizes that diabetes is the leading cause of chronic kidney disease. Chronic kidney disease can affect everyone, but people of African American, Native American, Hispanic, or Asian Pacific descent are more likely to be affected by chronic kidney disease. 45%, almost half of all chronic kidney disease cases are caused by diabetes. The fact that we don't know about it as much may be because diabetic kidney disease starts years or maybe decades after the onset of diabetic symptoms. That does not mean that it's not a severe problem for both the healthcare industry and the patients, of course. The current treatment options for diabetic kidney disease include dialysis and kidney transplantation. Just in the US, the annual cost of these procedures are approximately $45 billion. This is a huge financial burden that is mostly covered by Medicare, but some of it is also covered by Medicaid, private insurance companies, and a significant portion of it is covered by out-of-pocket expenses, which may pose a barrier to accessing care for patients. So in this talk, I'm going to talk about how kidneys normally filter our blood, and I'm going to explain how the elevated glucose levels in the blood, such as is the case in diabetic patients, damage this mechanism of blood filtration in the kidneys, and I'm going to explain what my lab is doing towards diagnosing the disease early and potentially delaying the onset of the disease. So in the kidneys, we have these cells that are called the podocytes. Podocytes is a Greek word that means cells with feet. And what these cells do is that they are not your normal cells. They look like a nice round cell, but they also have protrusions coming from them, much like the fingers on my hand that protrude from my palm. And the way that these cells are responsible for filtering the blood is that similar to building a sandcastle. So think about it like this. When you go to the beach and you want to build a sandcastle, you go where the sand is wet, and you can pick up the sand by crossing your fingers. And this would leave the water, drain the water from the sand that's now on your palms, but keep the sand on your palms. That's what podocytes do. These protrusions that they have interdigitate and they filter the blood, so they let the things that are not necessary for our body out, and they keep useful things like our blood cells and useful proteins in the bloodstream. Now, what happens when glucose levels are elevated is that these cells are damaged. You can think of the same example of going to the beach and trying to make a sandcastle and trying to make it while you have swollen fingers. Say a bee stung you and you have swollen fingers. You're not as efficient in picking up sand, or you wouldn't be as efficient in picking up sand because of the swollen fingers and not being able to interdigitate them properly. That's what happens in podocytes in the case of diabetes. Now, these cells start being affected by these elevated glucose levels early, but they still remain functional for a long time, and that's why the kidney disease in diabetes has a very long silent phase. Now my lab is focused on this silent phase and tries to find ways to revert this damage before it's complete and maybe delay the onset of the diabetic kidney disease symptoms, or even find a cure. So what we do is that we use a cell line in the lab. A cell line is a number of cells that are the same as the podocytes in the human body, but we are able to culture them in the cells in plastic vessels so that we don't have to take cells from humans or animals all the time. And these cells actually have all the necessary components that the podocytes have. So we have identified what we would call health markers for these cells. And these health markers, you can consider them as the checkup blood work that your physician orders every year to check if your body is okay, right? So you do the blood work and the physician reads the results and they say you're fine, you don't need any medication or any extra prescriptions. So that's what we do with these cells. We assess these health markers and we can tell if they are healthy or not. So we put these cells in high glucose levels, such as the ones that are found in the bloodstream of diabetic patients. And we have seen that these cell markers very gradually get lost. This loss is very gradual, much like the silent phase in the diabetic kidney disease patients will eventually lead to shutdown of the kidneys. So we are focused on finding what can prevent this loss. And what we have found is that vitamin D can be really helpful. The problem is that any helpful material such as vitamin D has to be given to the cells or provided to the cells before the symptoms start and before this loss of the health markers is complete. So currently we are trying to see what it is in the molecular level that makes vitamin D work, and by identifying the complete mechanism, is there any way to prevent or delay the onset of the symptoms. So hopefully in this talk you understood how kidneys work and what diabetic kidney injury is. It's delayed onset and it can have a huge impact on the patient's life. And hopefully you understood what my lab is doing to identify new ways to diagnose and treat diabetic kidney disease. Until next time.